Hey guys, welcome to the first video of 2022. This video will be covering sequences and series. Apologies for getting it out so late. It's been a bit of a crazy start to the year. I finished one degree in Jan and started another one in Feb. So it's been a bit crazy. If you are enjoying the content, please leave a thumbs up on the video. Please consider subscribing to the channel. Just a reminder that once we do hit 100 subscribers, I will be doing a live Q&A session for you guys to get to know me a little bit better. So without wasting any more time, let's jump into the video. Okay, so sequences and series. Let's have a look at the difference quickly between a sequence and a series. So a sequence is a set of numbers. Okay, so it's just going to be a set of numbers which has a relationship to it. Okay, so relation. Okay, whereas a series is going to be looking at taking that set of numbers and summing it. So we're going to take, this is sum notation, let's say from I equals 1 to n of the formula for our sequence. Okay, so series is the sum, sequence is then just a set of numbers, so such as 1, 3, 5, 7, 9, and so on. Okay, so that's all your odd numbers, which means we're looking at 2n plus 1 for odd numbers. So therefore the series for this would then look something like the sum of 2n plus 1, and then you can start at 1 and go up to n. Okay, now I just want to run over some summations. So looking at the summation sign, okay, this indicates the sum. So the bottom tells us where we start. Okay, so this means we'll start when I equals to 1 and we'll go up to, let's say, 5. So if I just choose 2n plus 1, okay, not n, sorry, let me just change that to an I so it makes sense. So what we're doing is we're saying when I equals 1, we have 2 plus 1, which is 3. Okay, then I equals to 2, that's 4, plus 1 is 5, and so on. So then 7 plus 9 plus 11. Okay, so all we're doing is we're starting at 1 and we're going up to 5. So 1, 2, 3, 4, 5. Okay, and then you plug that into your calculator and it will give you the total. Okay, now just some sigma, or some, not sigma, summation rules we're going to be looking at. If we're summing up a constant, so if we have the sum of just a constant c starting from I equals 1 to n, okay, it's pretty much saying c plus c n times, okay, which is then equal to c times n. Okay, if we have the sum of I equals 1 to n of just I, meaning we have 1 plus 2 plus 3 plus all the way so on and so on up to n, okay, this is going to be represented as n plus 1 all over 2. Okay, now if this changes to, let's say, n minus 1, then inside the bracket here that will just change to a minus. Okay, but for now, if it's just up to n, then it's n plus 1. And the last one, which you might need to know, equals this one. If I have I squared, is then going to be n plus 1 and then 2n plus 1 all over 6. Okay, so those are the basic ones that you need to know. Okay, so this is just I squared, which means we'll have 1 squared plus 2 squared plus 3 squared and so on and so on. So it's going to get big really quickly. Okay. Okay, so the first kind of sequences and series we're going to look at is arithmetic, sorry, which comes from arithmetic, which is plus, minus, times, and divide. Okay, that's your basic arithmetic. So this one normally has a common difference. Okay, so if we look at the following 7, 11, 15, 19, 23, okay, you can see that the difference between all of this is 4. Okay, so the relationship here is something to do with adding 4 on. Okay, so the common difference, which we represent by d, equals to 4. Okay, so let's just have a look at what's happening here. Okay, the first term, a1, is going to equal to 7. Okay, the second term, a2, is 11. But how did we get there? We said 7 plus 4. okay, which gives me 11, or we can rewrite this as a1 plus 4. Okay, now if you look at a3, we said we took this one over here, so a2, and we added 4. So we said 11 plus 4, which then gives me 15, or we can look at it as saying a2 plus 4. But now what's a2 equal to? Well, a2 we said is equal to a1 plus 4, so we have a1 plus 4 plus 4, okay? But 4 is my common difference, so we technically have this as a1 plus 2 times my common difference. Okay, now let's have a look at a4 over here, which is then going to be 15 plus 4, which equals 19. Okay, or we can rewrite that as a3 plus 4. But what did we see a3 was? A3 was a1 plus 2 times my common difference. Now my common difference is 4, which means this is equivalent to a1 plus 3 times my common difference. Okay, so you can see that when n equals to 4 over here, the number in front of my common difference is n minus 1. So the general term we then get to for Tn is then going to be a1 plus n minus 1 times d. Okay, so that's how we come up for the formula for an arithmetic sequence. Okay, now if we look at the arithmetic series, okay, so we're going to look at the series, okay, which we said was the sum. Okay, so now we're adding everything, 7 plus 11 plus 15 plus 19. Okay, let's look at how we get the term, or how we come up with that general term. So we know that a1 is equal to a1, okay, that's just general. a2 equals to a1 plus d, a3 equals to a1 plus 2d, and so on and so on. So let's see if we add up all these terms, it's going to be a1 plus a2 plus a3, so on and so on, which means I have a1 plus d plus a1 plus 2d, okay, and then we're going to add all this up all the way to n minus 1, a1 plus n minus 1 d. Okay, so now I can split the terms and I can group them, so I'll just have the sum of a1s, okay, that will go on and on and on, okay, plus I'll have d plus 2d plus 3d, okay, and that's also going to go on and on and on all the way to n minus 1 d. Okay, so remember, if I write this in summation form, this is just a constant, which means I have the sum of I equals 1 to n of just a1, plus now the sum of I starting at 1 going up to n minus 1. Okay, so I equals 1 to n minus 1 of I times d. Okay, because it's 1d, 2d, 3d, 4d, all the way up and up. Okay, so my rule for this says that if I want to find out what the nth term is, it's just going to be a1 times n. And remember, for I, it was the following. It was n, okay, times the top number, which was n plus 1, but now it's going to be n minus 1, all over 2 times d. Okay, so now if I take out the common factors over here, I'm going to take out a half and n, which means I need to multiply this by 2 because I'm taking out a factor of a half. So I'll have n over 2 a1 plus n minus 1 d. Okay, and this is the sum of my arithmetic series. Okay. Okay, the next group we're going to look at is the geometric sequences and series. Okay, so geometric means that there's a common ratio. Okay, so the sequence has a common ratio of r. Okay, so let's look at the sequence first. Okay, so that's my ratio. Okay, so for instance, if we look at the following 2, 4, 8, 16, okay, we can rewrite this to the 2 to the power of something. So this 2 to the 1, that's 2 to the 2, 2 to the 3, 2 to the 4, and so on and so on. So you can see that if I take this term and I divide it by that term, so 2 over 2 divided by 2, 1, is then going to give me a common difference of 2. Okay, and if we continue moving through with all of these, we'll see that my common ratio, sorry, is then going to be 2. Okay, so when we're looking at the general term for this, okay, so we can see that we have over here a1, okay, which is 2 times my ratio to the power of 0, okay, so that's just 2 over there, because anything to the power of 0 is 1, and then we have a1 times r to the 1, a1 times r to the 2, so on and so on. But we can see that for the first term, second term, third term, we can see that the power, or the exponent over here, is 1 less than the term I'm dealing with. So on the third term, it's to the power of 2. So Tn is just going to be a1 times your ratio r to the power of n minus 1. Okay, so if you're looking for the third term, it will then be T3 equals to 2. Your ratio is 2 to the power of 3 minus 1. And if you plug that in, you will get the third term. Okay. So that is that one over there. If we now look at the geometric series, okay, which is then the sum. Okay, so this here is your general term for your sequence. So if we look at the series for the geometric, now we're adding up everything. So it's a1 plus a1r plus a1r squared, so on and so on. Okay, so let's see how they come up with this term of Sn equals to a1 1 minus r to the n all over 1 minus r. Okay, so how did they come up with that? Okay, so let's have a look. I'm going to look at my first sum. Okay, this is called the partial sum. That's representing your partial sum. So that's a1 plus a1r plus a1r squared, so on and so on. Okay, now I'm going to take this and I'm going to multiply it by the common ratio of r. So r times Sn is now going to be a1r plus a1r squared plus a1r cubed. Okay, so this one is going to go all the way up to a1 rn minus 1, whereas now I've added 1, so this is going to go all the way up to a1r to the n. Okay, because I've multiplied everything out by a common ratio r. Now what I'm going to do is I'm going to subtract these two from each other and see what's left. Okay, so it's Sn minus r times Sn, which is then going to be this first sequence. So it's going to be a1 plus a1r, okay, plus everything up to a1 rn minus 1. Okay, now I'm minusing the second set over here. So I'm just going to write it at the bottom. That's a1r plus a1r squared, and that's going to go all the way up to a1r to the n. Okay, so let me write it like this: n minus 1 plus a1r to the n. Okay, so now we can see that that and that's going to cancel out, that and that's going to cancel out, everything's going to cancel out all the way to a1 rn minus 1, all the way to a1 rn minus 1, which means what am I left with? I'm literally left with a1 minus, okay, remember you distribute the negative in, minus a1r to the n. Okay, and on this side I have Sn minus rsn. Take out common factors on both sides. Sn 1 minus r equals to a1 1 minus r to the n. Okay, now I just divide this side to get Sn on its own, and I end up with a1 1 minus rn all over 1 minus r. Okay, that's how we get to this formula. Now remember, with geometric there's conditions to it. What happens if r is less than 1? What happens if r is greater than 1? Okay, so looking at this over here. So if we look at the function of r to the n, so if r is greater than 1, okay, we have an exponential function which does something like that. So you can see that this term is just going to tend towards infinity. It's going to get bigger and bigger and bigger and bigger forever. Okay, but now let's look at what happens if r is less than 1. So if r is less than 1, it means it's a fraction, which means we have 1 over c. Okay, so r equals, let's say, 1 over something, 1 over 2, 1 over 5. Okay, but this is still to the power of n, which means now we have a really small number. So 1 over c to the power of n. Okay, so 1 over c to the power of n means that this number is getting extremely small. So let's have a look at that graph. So this graph is now going to look something like this. Okay, which means as we go towards infinity, this number is going to get really, really close to 0. So we can say, we can approximate that it's going to be 0. Okay, so for r less than 1 or greater, not equal to, greater than -1, okay, this is one of your conditions for conversion. Okay, the series the series will converge. So then this here goes to 0 because this function goes to 0. So I'm left with Sn equals to a1 all over 1 minus r. And that's how they come up with that formula. Okay. Okay, the last one we're going to be looking at is a quadratic sequence and series. Okay, so quadratic means that there's going to be a second difference. Okay, remember quadratic form is ax squared plus bx plus c. Okay, that's a quadratic function. So now this sequence and this series is going to have the form of a quadratic function. Okay, so if we look at the following, we're going to have 6, 11, 18, 27, 38, 51. Okay, so first thing we're going to notice, the difference between that and that is going to be 5, that's going to be 7, that there is going to be 9, 11, and so on. So this is where the second difference comes in. So the difference between there and there, these are all 2. Okay, so quadratic will always have a second common difference. Okay, now sometimes we get told we have to memorize how to solve this, because then you have to use the following: 2a equals to your second difference. Okay, and then you have to use 3a plus b and then a plus b plus c. Okay, but where does all of this come from? Okay, well, let's have a look at the quadratic equation. So if I have x equal to 1, then I have a1 squared plus b1 plus c. Okay, now the second term is going to be x equals to 2. So now I'm going to have a2 squared plus b times 2 plus c. Okay, and the next term is going to be a3 squared plus b3, okay, plus c. Okay, now let's have a look at the first difference between everything. Okay, so yeah, technically I have a plus b plus c as my first term. Okay, so that's 1. Then the next term is 4a plus 2b plus c. My third term is then 9a plus 3b plus c. Okay, that's my third term. Okay, so now let's have a look at the differences between it. If I take this one and I minus that one from it, what's going to be left? Let's have a look. The c's will cancel out, definitely. Okay, there's a b and there's a b, so I'll be left with 1b. And then a and 4a minus a, okay, we'll then end up with 3a plus b. Okay, so the general term for my common difference, okay, for the first difference, sorry, not common difference, but for the first difference is given by this here, because my first difference will follow this rule. Okay, remember, a is the coefficient of x squared and b is the coefficient of x. So if we had to follow that throughout, it will generate this sequence at the bottom here. Okay, now to get my second common difference, okay, let's do the difference between these two quickly. There's 4a, there's 9a, so the difference is going to be 5a. There's 3b, there's 2b, so the difference is going to be just b again, and the c's will cancel out. Okay, now let's look at the second common difference over here. If I take this one and I minus that one, my b's are going to cancel. 5a minus 3a is just 2a, and this is where we get this first part, that 2a equals my second difference. Okay, so when we solve for a, b, and c to find the quadratic form, this is where it all comes from. It comes from your sequence. Okay, now the sum of your quadratic form, okay? It's a little bit more complicated and so on, okay? So the series, you guys don't need to know how to get to it and how to come about it and that. It is quite complex, but if we look at just the general term, okay, so x squared, if all my other coefficients are 0, if we just look at x squared, this is then going to be that sum that I gave you in the beginning. That's just going to be the sum of I equals 1 to n of I squared, okay, and that gave us n plus 1 to n plus 1 all over 6. Okay, now if there's another term, so if it's I squared plus I, okay, then you're just going to use the summation of I, okay, so then you'll have the sum of I squared from I equals 1 to n plus the sum of I from I equals 1 to n, and you'll add those two sums together. So you'll end up with this term n plus 1 to n plus 1 all over 6 plus then n plus 1 all over 2. Okay, but this, yes, you'll have to know how I squared works and how the sum of I works, but at this point in time, the big question for quadratic is finding a, b, and c. Okay. Okay, so just a basic example for your quadratic formula. So we want to find the general term Tn in this form of here, which means we need to find a, b, and c, and then we want to find t of 20. Okay, so we can see that we have 4, 15, 32, 55, 84. So the difference between that is 11. The distance between 32 and 15 is then going to give me 17. Then 55 minus 32 is then going to give me 23, and so on and so on. So you can see that the difference between 11 and 17 is 6. The difference between 17 and 23 is 6. Okay, so my common difference, my second common difference, equals to 6. Okay, now remember we showed how we got to the formula to find a, so we know that 2a equals to 6. So a in this is going to equal to 3. Okay, now to find b, we said it's 3a plus b is going to equal to 11. Okay, so this number over here, that's going to be 11, and then we're going to substitute 3 times 3 plus b equals 11 over there. Okay, and then if we solve for b, we're then going to get 11 minus 9 is then going to give me 2, and then we have a plus b plus c is going to equal to my first term, which is 4. Okay, so then we'll have 3 plus 2 plus c is then going to give me is going to equal to 4. So therefore c is going to then equal to 4 minus 5 is -1. Okay, so my Tn is then just going to equal to 3n squared plus 2n minus 1. Okay, now if we want to find t of 20, we just substitute in the 20 into n's place, plus 2 times 20 minus 1, so 3 times 20 squared plus 2 times 20 minus 1 gives you 1239. Okay, so just a basic example how to find a, b, and c. Okay, so if you did find today's video helpful, please leave a thumbs up on the video. Once again, please consider subscribing to the channel. If you have any questions, leave them in the comments below and I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.